Olive,
What's up, man?
man, just it's Friday.
It is Friday.
That's what's up.
It's a much needed day of the week.
Yeah, I didn't even realize it's Friday until like this morning. Like this week, it's just zoomed by. So,
Oh, me too. Yeah. It has been just, a week of strange things going on. And then we're going to get a bunch of like super cold weather. So I'm not looking forward to it. We can just skip on to spring if that's cool with you.
That is always good with me. I'm at a crossroads because I have two Chris's and I feel left out today. So today we are joined by a special guest, and I will actually let him introduce himself real quick.
I'm Chris Seaton. I work for the Oracle Labs virtual machine research group on TruffleRuby, which is a new implementation of Ruby.
All right, and thank you for joining us.
That's great.
So let's just dive right in. Do you mind just giving us kind of a high-level overview of what TruffleRuby is?
So TruffleRuby is a new implementation of Ruby, but it's built on code from MRI and Rubinius and JRuby. We're trying to bring new performance to Ruby, but also bring new tooling. The most significant thing it brings for most people will probably be the higher performance. We do that by a really powerful just-in-time compiler, and it delivers really good performance improvements on real-world code. We're getting to the stage where we're starting to look at running Rails applications now, but it also brings lots of interesting tooling, so debuggers and introspection and stuff like that.
Awesome. And if I'm not mistaken, TruffleRuby, it actually came out of kind of your like PhD project or something like that?
It started as my internship. So I went to the US to Oracle Labs and I got asked to try doing a new implementation of Ruby using some technology they had. And the internship sort of snowballed from there. So I stuck around for 6 months in the US working on it. And when I went back to my PhD research sort of became TruffleRuby. And then Oracle hired me when I finished to keep working on it, and it's been going ever since. So it's been a sort of eternal internship project that's grown and grown.
That's awesome. Or is Oracle then using this stuff internally for projects, or is this something they just want to support and see exist in the world?
So some people I speak to think that Oracle's got some massive Ruby deployment somewhere that they must be trying to run on TruffleRuby, and that's why they're doing this. And that's not really the case. It started as an internship project, and that means that it was just let's try and see what happens sort of project. And because it's been successful, we got good results quickly. We kept going with it. So there's no big secret reason why Oracle wants to build it. We're simply interested in running Ruby programs faster. It's a research project it started out as. So we're interested in the research result about how to make a complicated language like Ruby faster. That was an open research program when we started. So we're interested in the research as well as using it.
Gotcha.
Are there any other languages that are kind of being experimented with?
Yeah. So the approach the wider project is taking is we want to be able to make all languages fast. So a language like JavaScript has got really good performance, but only because of Google invested a lot of money in doing that. And the way it was being done in the past, it had to be done individually for every language. So if your language didn't have a massive sponsor like Google, you weren't going to get a fast implementation. What we did was we made a new technology that makes it easy to make new high performance implementations of languages. And Ruby is one of the languages we tried it on. JavaScript was the first. We're now using the same technique for Python and R, which is a statistical language. And for languages like C and C++ as well, which you wouldn't think about as being just-in-time compiled, it works for those languages as well. So the breakthrough was that we could do something that worked for all languages and make all languages have the same sort of good performance as if someone like Google had invested all that time and money in them.
That's awesome. So for specifically TruffleRuby, what are some of the things, I guess, if you want to talk about performance or just like implementations, what are some of the things that make it kind of unique compared to like MRI?
So having a just-in-time compiler was something that was unique compared to MRI in the past. Now, of course, MRI is getting a new just-in-time compiler. And JRuby has always had one via the JVM. Rubinius had one in the past. But TruffleRuby's just-in-time compiler is, I think it's an order of magnitude more powerful. It's a whole step above those previous efforts. And that's not just me saying I think mine's fantastic. It uses a really powerful technique called partial evaluation. And it's proved to be really good at optimizing through idiomatic Ruby code. So the example I often give is if that previous efforts to optimize Ruby might try and make things like adding together numbers fast or make an if statement fast or something like that. But the problem is Ruby code has so little of that sort of logic in it. Ruby code is often method calls stuck together with other method calls and blocks. And even if you make each of those methods on their own really fast, the program would still be slow because it's lots of calls to those methods. It's all calls to other methods. It always goes off somewhere else. And partial evaluation is really good at inlining through methods and inlining through complicated method calls like metaprogramming, inlining through calls to eval, dynamically defined methods, that kind of thing. TruffleRuby's techniques are excellent at going through the kind of metaprogram that's idiomatic in Ruby, and that's a really big difference.
Cool. Chris, do you have any other questions before I keep going?
No, go ahead.
Cool. So you kind of mentioned I guess you're ready to start kind of trying to get this thing working with Rails, which I imagine is like kind of a big milestone. And I don't imagine it's probably the easiest thing. What are kind of some of the challenges to getting a Ruby implementation to work well with Rails?
When I started, I didn't know anything about Rails. What's more, I didn't actually know anything about Ruby. So I was asked to go to the US to try and work on this internship project. And I read a Ruby book on the flight over. And my first experience of implementing Ruby was using Ruby. And personally, I've got the same sort of problem with Rails in that I'm not a web programmer by background. I don't always have a great understanding of how Rails is used. I don't always have a great understanding of the kind of patterns you get in Rails applications. Since then, we've hired a couple of people who do know a lot more about Rails than I do. And they're helping me out to understand it. I've got a better idea how it works. But understanding the complexity and understanding where a Rails application is going and why and what's calling what is very tricky. It's also very monolithic. It's quite hard to break down individual components. It's sort of a large Rails application, even if you just do a Hello World to-do list application, the volume of code involved in that is absolutely massive. And when you're working on a Ruby implementation, you can get quite fundamental things going wrong. So if you break some array operator, things can go off into the woods very quickly. And then it's quite hard to understand how it's gone that wrong when the basic parts of the language aren't always guaranteed to do exactly what they should be. And we can often fix individual bugs fairly easily. If you give me a file and say, this isn't doing what I expect to do, that's quite easy to debug. But when you're looking at all the code involved in a huge Rails application, that's a bit trickier to debug.
Do you have like a spec of how Ruby works that you're building towards to get sort of completeness? Or are there like things that MRI does that just are kind of like the way that it does it, but maybe not necessarily how it has to be implemented?
So there's a set of tests in MRI. They're sometimes quite hard to deal with. The tests are often very long with a lot of asserts in a single method. And because of that, someone built something called Ruby Spec. It was started in the Rubinius project, actually, which is a much more modern set of very small, precise tests that you can use to, I suppose you use it to document the semantics of Ruby in a way. So they went through and trying to work out what happens for every action in Ruby, and they wrote a spec for it. But when you're implementing Ruby again, you sort of get to the limits of how useful that can be because you have to figure out for yourselves what Ruby is supposed to do in the first place. And often you get down to you simply have to read the C code and implement it. Understand what it's trying to do by simply what it does by looking at the code. We've got a philosophy in our project that we want to implement Ruby as it is. So it's very tempting when you look at how Ruby behaves to be critical and say, I'm not sure it's supposed to do that. That doesn't seem very sensible. But we try to just always implement it as we find it is without trying to reason too much about it, because sometimes you can get quite frustrated trying to understand why stuff works as it does.
Yeah, that makes sense especially on a language as complex as Ruby. Just if you were trying to refactor it sort of as you're building your version of the language, you might end up with different results on accident because maybe you just missed one little thing that actually was important to keep as you went.
Yeah, and it's often quite subtle. For example, maths operators, you'd think, A plus B is fairly simple. But when you go down into the rules about how B is coerced to be the correct type to work with A, it gets very complicated, very tricky. There's sort of quite a long chain of method calls it goes through to convert the types, and then it may want to be the priority of A is more important, or the priority of B's type is more important to determine which type to convert them both to. So even the simple stuff, quite complicated rules in there.
Wow.
I mean, when you use it, it all seems quite natural, but
right.
Getting that natural behavior is complicated.
Wow. Yeah, like that's something just as a user, like I wouldn't think of. So kind of like you mentioned that when they do testing, it's like one method has a bunch of asserts. Are you actually trying to copy like the way Rubinius tests in the way you test, or do you kind of have your own unique approach to it?
The Rubinius project started this Ruby spec project, which is a nice set of tests. I can't remember. I think they stopped taking contributions from other people for their spec suite a while ago. So we forked it into something that MRI now has. So MRI now has this set of specs as well. But the people who work on MRI don't update it themselves. They tend to update the tests. So what we do is we go and look at what's changed in Ruby change logs and implement specs for the same thing. But the code we use originally came from Rubinius, yeah.
Okay, so anytime like a new version of Ruby comes out, you actually have to go through the changelog and then rebuild those tests on your version of Ruby spec.
The JRuby people work on it as well because they also use the specs, and we get people contributing specs to the central place. We'd like it if the specs were the central way everyone tested and implemented Ruby, but it's not quite the case at the moment. So we use the MRI tests as well as using the specs.
Okay. So I know like JRuby isn't a like Oracle sponsored project, but do you work with JRuby team at all?
Yeah. So we started building using JRuby code. We used their parser and a few things like that. And after we announced the project in open source, we actually merged into JRuby. So TruffleRuby was like an optional backend for JRuby originally. And we did that so we could more easily borrow code from them. So they already had implementations for lots of things, and we reused that code. But then over time, we actually forked back out of JRuby to become a standalone project again, because we wanted to simplify a few things and to change our direction for how we did releases and things like that. So it was tricky to have them in the same repository. So TruffleRuby has been part of JRuby at one point, and that's come out again. We still share quite a bit of code. We have a few different priorities to JRuby. JRuby is great for running standard Ruby code, but they also have got a priority on interop with Java. Our main focus is probably running just ordinary Ruby code. And we also want to run C extensions. On JRuby, use Java extensions instead of C extensions. So we want to run the standard C extensions.
Okay, fascinating. So it's like, yeah, because with JRuby, you can use like any package that runs on the JVM pretty much. And okay, so with TruffleRuby, you're actually trying to be able to keep kind of the native Ruby, like you can run C extensions.
Yeah. And if you have a Java library that you want to use, then you can use that from TruffleRuby. We've got really great support for that. But we don't want people to have to do that for basic gems. We want people to use the standard stack, so the standard database drivers and things like that, rather than having to do the Java versions. But you can also run Java libraries from TruffleRuby. And because of we're using the same system for lots of different languages, you can also use Python libraries from TruffleRuby, or you can use JavaScript libraries from TruffleRuby. So going for a sort of uniform approach that lets you use any other language rather than putting specific effort into just interop with Java.
That's super cool. What's the interface like for using, like if you wanted to use a Python library in TruffleRuby. What do you have to change to make that work?
There's a way to eval code. So, like Ruby's eval takes a string and executes it. There's one of those that works with any other language. So you can eval a Python import statement and then eval to return a module. And that simply appears in your Ruby program as an object like a Ruby object. You can call methods on it, use operators on it, and it works as if it was like a Ruby object. Wow,
that's awesome. I didn't realize that. That's so super cool.
Yeah, we talk about this as a kind of polyglot programming, and we're getting a bit philosophical, but the idea is we want to democratize languages. So at the moment, when you pick a language, you invest quite heavily in things beyond just language, right? You invest in the ecosystem of libraries, and you also invest in a sort of performance characteristic. So in the past, if you chose Ruby, you were sort of committing yourself to not having great performance, but getting fantastic libraries. We want to make it so that you can pick any language you want and get access to libraries from any other language's ecosystem that you want and great performance. And this means that the choice about language becomes more actually about the language. So I want to use Ruby because I enjoy programming in Ruby. I don't want to get low performance for that. And I don't want to be restricted to just Ruby libraries from that. And this way that Graal becomes a sort of nexus where you can use any language and then you can use any libraries and you get great performance for everything.
That's mind-boggling. Like Chris, I had no idea you could do that. So could you use, in theory, like Ruby libraries in a Python project on Graal?
Yeah, exactly. So we've got a few demos where we have a Node application and we want to use a Ruby library. So you can simply import the Ruby library and use it like it was JavaScript code. And the same, you can use like any combination. So you can use R with Python or JavaScript with Ruby. And any other combinations you want to.
That's awesome.
So how does that work between like a language with types and one without?
Well, that's where it gets interesting. The languages we've implemented also include languages like C and C++, and they work in the same way. I've got a demo I do where I've got a C struct and I pass C a Ruby object and I cast it to this C struct. And then when I access fields of the struct in C, it actually reads the fields back from the Ruby object. And it converts them to the types as needed. But even in a language like C, we can still do this kind of interop. And I can give you a C array, but it's actually a Ruby array. So you've got a pointer to a string, for example, in C. It can actually be a Ruby string that's backing that, but it just transparently reads back into Ruby for you.
That's fascinating. Is that like what's the most complicated part of this? It seems like all of it is just got to be kind of a very complicated and almost a nightmare to like build, but you guys are clearly making really good progress on this. So like what
we did was we added a new kind of abstraction. So in our system, what you do when you want to implement a new language is you write an interpreter. And what you'd normally do from there is you'd write a specific JIT compiler for your language, and that's where all the work is. But what we've done is we've written a program that takes a interpreter as an input, and it produces a just-in-time compiler from that interpreter automatically. This is a mathematical trick called partial evaluation. It's got a lot of technical detail about it, but basically it takes an interpreter as input and gives you a compiler as the output. And because we can understand the program as a sort of an input, we can write ways to inline between different languages, things like that. So the interpreter is like a data structure that the compiler can recognize.
Okay, that makes sense. Yeah. So how's the performance of like TruffleRuby right now compared to say like I don't know what the latest you guys have tested against like Rail or Ruby 2.6 or something like that?
So if you run a micro benchmark, so a trivial little benchmark that runs a loop and adds numbers together, then it's often thousands of times faster. If you write something a bit more complicated, then it may be 10 times faster. For example, we can render ERB templates at around 10 times faster than JRuby and MRI. And that's the best sort of real world example I can give you at this kind of stage. If you have a Rails application which renders templates as outputs, we can do that around 10 times faster than a standard implementation of Ruby.
Wow, that's fantastic. And then to get more performance, is it a lot of little things here and there just to improve?
Yeah, it's often the case that there's something blocking things from working well, and we just need to go in and remove all those little blockers, but that does take some time.
Yeah, and it's just probably a matter of like finding all of those little places here and there that are just kind of obscure and not super obvious, because you don't have like one main chunk that's like, oh, this is slow, we obviously need to optimize that. It's probably many, many little ones.
Yeah, so we get quite a few GitHub issues now. People are trying it, 2 or 3 a day. And each time we look at those, it's always quite easy to fix the problem. When presented with a specific thing that's not fast or that doesn't work, you can usually fix them pretty quickly. But there's still quite a long stream of them coming in.
Does Ruby 2.6's new JIT affect what you guys are doing at all? Are any of those like tactics they're doing going to help out with TruffleRuby?
The best thing that's happened so far has been that because of their now working with a JIT, they're changing the way they benchmark to accommodate JITs. So when you're benchmarking an interpreter, things are quite straightforward. An interpreter always performs every action in the program. It's not optimizing it. So Ruby benchmarks in the past were often written in such a way that they worked as if they were running on interpreter. But when you run with a just-in-time compiler, you get lots of really complicated, unusual effects. And they're changing their benchmarks to accommodate those effects. These effects are things like warm-up. So a program with a JIT gets faster as it runs. So you can't just measure it for half a second at the start. You have to give it time to get going. And now that MRI also has that problem, people are writing benchmarks to accommodate it. And that's really helpful to us because it means we can use the same benchmarks as everyone else.
Cool. I wanted to ask, you mentioned a little bit earlier about one of the benefits of what you guys are doing, or what y'all are doing, is actual tooling. You can do some cool thing with tools. Do you mind explaining some of that?
Yeah, we're trying to, in the same way that we provide high performance for all languages, we want to provide good tooling for all languages. So any language which is written using our system automatically gets things like debuggers and profilers for free. In the same way that we can automatically write a JIT compiler for a language, we can automatically write a debugger for the language as well. And the interface we've chosen to use is Chrome. So, Chrome's DevTools normally works with JavaScript, but it's got a network protocol you can use to connect to it. And the Graal system will connect that protocol automatically for your language. So you can debug Ruby using the Chrome DevTools debugger. And you can also debug Python using the Chrome DevTools debugger, and R and C. And if you've got a program written in a combination of these languages, you can actually debug the combination of languages. So you'll see a list of stack frame activations, and there'll be a Python one, then a Ruby one, then a C one. And it works for all the languages. So you can simply click on that and see C local variables. Click on the Ruby one, you'll see Ruby local variables. Step through the different languages. So you get one debugger that works for all the different languages at the same time.
So this project is like way bigger than I even thought it was.
Yeah, it's a big project. Oracle's got about 35 people, I think, something like that, maybe more now working on it. And we've been going since around 2012, and TruffleRuby's been going since 2013. So it's a pretty big investment from Oracle, and that represents how important Oracle thinks this is, this idea of one system that can run all languages, run all ecosystems, provide great tooling, provide great performance for all of them. We think this is a really big idea.
Yeah, this is like way larger than I thought it was. Are there drawbacks to this approach? Like, are there things that get more hard to work with or slower or something? I mean, obviously, like boot up is going to be a little bit slower. But
yeah,
that's
startup is a bit slower. Memory consumption can sometimes be a bit higher for small programs because we have this data structure, which is the program, which we can analyze. So we have to keep that data structure around. We think that over time this will get amortized. So if you were running 10 servers before and now you only have to run one, then you only need one copy of the program rather than 10 before. So we think that as you scale out, that extra cost will be less significant. Startups are a really interesting one. Glad you mentioned that, because that used to be quite a big problem. It would take a long time to get going. So what we actually did was we wrote a new ahead of time compiler for Java. What this does is it takes our interpreters written in Java, and this takes our Java interpreters and converts them to a normal binary, like you'd written it using Go or C or something like that. So they don't need a JVM to run anymore, and they can start up instantly. And a really fascinating breakthrough we had here is that when you ahead of time compile the program, you could run it for a period of time and then run the compiler on the program which has already started. What you get is an executable that when it starts, it resumes the program at that point. So our core library is written in Ruby, like it is on Rubinius. And normally that means you have to parse it and execute it on startup, which makes things a bit slow. What we do is we parse and execute the core library, then we compile the program with that state of it already being parsed, and then the executable just appears in memory and can start running your program. And we're looking at using this to solve some problems with Rails startup. So even on MRI, starting a Rails application would take a while, right? What we want to do is be able to let people initialize their libraries, and then at compilation time. So when they run their executable, Rails is already there running.
That's really cool. It's kind of like I think, Passenger, some of the web servers can get it up and running so that it's ready to process the next request right away. And it's kind of a similar concept there, it sounds like, which is really fascinating. I didn't even realize you could do something like that. And like
if you're wondering what's why all these things are being done in one project, what's the thing that's enabled it? What we did was we wrote a new compiler in Java, and we realized that because it's written in Java, it's just a library, right? It's just Java code you can use anywhere. So we realized we could, as well as using this compiler to be a JIT compiler, we can also use it to be an ahead of time compiler. So we talk about being one compiler to rule them all. It's a single native code compiler you can use anywhere to do anything.
This is so exciting. Before we move on, I guess kind of away from TruffleRuby, is there kind of like anything else we haven't maybe asked about the project that you think is important or excites you about it that you'd like to share?
We're getting to the point now where we want to start running Rails applications. What we're doing is we're sort of inverting Travis. Our plan is to, instead of persuading all the gem maintainers to test on TruffleRuby, because it's an extra burden not everyone has time to do for all the gems out there. What we want to do is test people's gems for them. So our plan is to, for every gem in Ruby Gems, we're going to test it locally on our systems. And then we'll have a service that tells you whether that gem works or not on TruffleRuby. So we'll take on the burden of getting the whole ecosystem bootstrapped on TruffleRuby and working, rather than having to pester all the gem maintainers individually to ask them to test on TruffleRuby. Because a lot of gem maintainers still don't test on JRuby or Rubinius, even though those have been around a long time. We think that's the solution to getting the ecosystem ready to run on TruffleRuby.
So are you actually just going to go through hit rubygems.org and just grab every gem and test it out?
Yeah, it's a bit tricky because the specs aren't always in the gem which is distributed. So you have to go back to the GitHub repo. And in some cases, really old gems have been published and they were on something like RubyForge in the past, which isn't around anymore. So sometimes the specs aren't really there anymore, which is a bit tricky.
That's so awesome. Chris, Chris Oliver, do you have any questions about TruffleRuby before we move on?
What is it something you can just install with Ruby build, or do you have a different install process for it for anybody that wants to try it out?
Yeah, it's in all the standard Ruby version managers now, thanks to the people in those projects who helped us do it. So you can RBM install TruffleRuby, and similar commands for the other projects. And yeah, you can just use it like a standard Ruby. If you want to use it as just for running Ruby code, and you don't care about Polyglot or Java or anything like that, the idea is it works as just a complete drop-in replacement. So you shouldn't have to learn anything else.
Do you have to do anything else if you did want to do the polyglot version?
Yeah, so there's some different libraries that we have that are bundled in it that help you do that sort of polyglot stuff. But you don't have to install anything separate to use those now.
Okay, cool. That's amazing.
Awesome. So, Chris and I on this show, and I think you mentioned this to us too before you came on, we usually talk about side projects. And you mentioned you have, I don't know if it's still active, but a mighty big side project you at least used to work on. Do you want to tell us more about that?
Yeah, so when this was around 2010, 11. So I was in the army at the time. I'd done a master's in computer science, but I went into the army after that. And I was looking for something I wanted to apply to PhDs, and I needed to show like a program, and I sort of kept my hand in and knew how to work with technology and stuff. So I was thinking about how to do that to prevent potential PhD advisors. And I didn't really know the term side project or what the big side project thing at the time. But I worked with a couple of doctors who I knew socially. They wanted to make an app for helping people who are burned. The idea is if someone's very seriously burned, you need to put fluids into them. I'm talking about if you get a vat of boiling oil on you, so really serious burns, you need to put fluids in people to resuscitate them. But if you put too much fluid in, it's harmful. And if you put too little, it's ineffective. And the calculation to work out how much fluid to put in someone is absolutely brutal. It's quite a complicated formula. And we found that doctors simply got the maths wrong, as well as getting the formula wrong. And the errors were quite large and quite harmful. So we decided to make an app to work out how much fluids to put in people. It's really straightforward sort of tech, really. The program's not complicated because we're implementing an equation basically with a user interface. But what we did was we decided to tackle some of the hard problems head on. So if you have a phone with a medical app on it, is that then a medical device? And everyone had been sort of skirting around this issue and pretending it wasn't the case. We decided to actually get the app regulated by the medical authorities in the UK. And we were the first people who tried to do this. And it became the first medically regulated by the government medical phone app in the UK. And one of the first in the world as well. And the great thing about this is people actually use this. I still meet doctors every now and again, sort of socially and stuff like that, who say they use this app actually to treat people. It's been featured in a couple of documentaries and things like this. And it turned into quite a big side project. I'm not involved with it anymore. We passed it on to someone else because of, if you think TruffleRuby is complicated, you should try maintaining an app for iOS. It's an absolute nightmare. It's not cut out for that sort of programming.
Wow. So like you knew a couple of doctors that said they wanted to do this. You guys got together.
Yeah.
And
so doctors do side projects as well. People think it's unique to computer scientists, and it's not. To keep their career going and get people to get their name out there and stuff like that, they do side projects as well, actually. But they often do like a book chapter or something like that. And we realized we could do an app as something a bit more interesting than a book chapter.
That's awesome. And so somebody has taken over this app now. Was it just like a free app? Or
yeah, it was always free. And the idea was that because doctors don't often see burns patients, that sort of really serious burns. And that's partly why they got the equations so wrong, because they didn't often do it. And the idea was you could say to everyone in the hospital, whether they worked in burns or not, download this app, and then you've got it in your back pocket for that day you need it. And because it was free, the hospitals could say to the doctors, install it, and everyone would just have it on their personal phone because there was no cost to them. We did based on the success of the app, we did some consulting later on with some big multinational pharma companies and things like that. But the actual app itself was always free. Yeah.
That's awesome. So you said this app was like one of the first that was actually like regulated by the government in terms of like healthcare.
It was the first in the UK and one of the first in the world. And what it turned out was everyone was pretending they didn't have to deal with it. They were pretending it wasn't an issue and it would go away. We decided to sort of tackle it head on, grab the bull by the horns. And we realized actually the regulators were quite reasonable. And because we were the first people to do it, we actually got to have a conversation with them. And they said, we're not sure how to regulate this. What do you think would work? We presented a plan for testing the app and showing that it would do what we said it would and things like that. And that became the recommended way of testing apps for regulation.
Wow, that's awesome. So no more iOS apps for you, though?
No, it's more complicated than writing just-in-time compilers. I don't know how anyone manages it.
I've never written a compiler, but iOS isn't the simplest thing to work with.
It's all the key signing. I think that was the worst thing I remember about it now. Like my keys would expire and I wasn't sure how to back them up, and it's just horrific.
And I guess that time that was pre-Swift still, so that was Objective-C.
Yeah. Oof. People think JIT compilers are complicated. I don't want to lie and say they're really simple, but they are nicely contained. So a JIT compiler is one function, right? It takes the program as input, that's one parameter, and it produces an array of bytes as output. That's the machine code to install on the system. Yeah, there's lots of complicated data structures and algorithms in the middle, but in terms of controlling the program, it's quite easy to get a grip on it. You don't have to upload it to Apple. You don't have to key sign something. You don't have to have some tool installed in your system. It's just one function. It's easy to see what it's doing, control it, get a handle on it. That's why I like compilers, really.
That's awesome. Well, I think that's all the questions I have. Chris, did you have any other questions?
No, well, that was pretty fun.
This is awesome. Thank you so much for joining us. I know it's not too early where you're at right now. So do you have anything else you'd like to share? Maybe where people can find out more information about the project or you?
Yeah, if you Google for TruffleRuby, so TRUFFLE Ruby, you'll find it on Google pretty easily. And there's a GitHub repo. There's a website aimed at people who might want to be customers. There's lots of articles because it's a research project. We do a lot of writing. So there's papers about it and lots of blog posts and stuff like that. So there's tons of information there. And if you want to talk to us about what we're doing, there's lots of contact points and stuff like that. We're in a Gitter room and stuff like that. We're getting to the point now where people can start trying it. And if you've got code which doesn't run as fast as you need it to or is hard to debug or something like that, come and talk to us and we'll see what your use case is and see how TruffleRuby can work with it.
Awesome. Well, thanks again for joining us. And Chris Oliver, I will see you next week.
All righty.
Well, I'll talk to you next week. I won't see you.